All right, so in this section, we're going to be finding the confidence interval for the population mean, remember for mu, when sigma is not known. So in this case, we're actually going to be using the t-distribution. So a t-distribution is very similar to the z-distribution, but it is different because we don't actually know the population standard deviation. The notation we use for t is we have t and then we have df. This is degrees of freedom, and how you calculate the degrees of freedom is n minus 1. And you can use a table. There's a t-distribution table. And what you would do is you would determine your degrees of freedom, and then it gives you the alpha depending on your confidence level. And then you would kind of say, all right, so if the alpha is 0.05 and the degrees of freedom is 10, and you kind of come across and you find your the t value in accordance with those values. Woo, excuse me, y'all. All right, so again, in your textbook, you can find your t-distribution table. You can also find one online. We'll also be using Excel mainly for these because they don't have every value. If you take a look here, after 60, we jump to 80, and then we kind of lose values here. So we will be using Excel, but this is a t-distribution table. The table also only gives you values to the right, so that's something to consider as well. It gives you the probability greater than. So we want to compute the t-value for alpha of 0.025 using 2, 5, and 50 degrees of freedom. So I just dropped those table values right in our here, and so we're going to find the t-value associated with 0.025 and the degrees of freedom of 2. So let's take a peek here. So degrees of freedom 2, 0.025 there. So we're going to come across, come down, and so it's going to be 4.303. If we have 0.025 degrees of freedom 5, we'll go over to 5, and because it's so tiny, same column here, we get the t values 2.571. And if we have 0.025 and 50, we'll go all the way over to 50. So 0.025 last row, 2.009. So again, the t-distribution is great. The table is great if we can use the table, if those degrees of freedom are available. But to use Excel, which is what we're going to be doing from here on out, we're going to use this. So this is what you're going to type into Excel. TINV 1 minus alpha, comma, the degrees of freedom. So if we were to type them in, this is what we would do. So again, if this is our alpha, we would type in 1 minus 0.025, comma, the degrees of freedom, and it would give us those values back. So go ahead and give these a try. And I encourage you to try Excel and then press play when you're ready to see the solutions. There you go. All right, so now let's go ahead and grab our confidence intervals. So when we're trying to find a confidence interval for mu, when sigma is not known, again, when it's known, we use the z's. When it's not known, we use the t. And so the only real difference here from what we were doing before is we've got this t value here, and it's t alpha over 2 degrees of freedom. So we have to calculate that value, and this is our sample standard deviation. And so everything else is actually the same. So in example 2, we want to estimate the mean miles per gallon for ultra green cars. And so we've got this list here for 25 cars, and this is in your data files. Use this information to construct the 90% confidence interval for the population mean. Assume that it follows a normal distribution. So again, our formula here is we've got, this is going to tell us our confidence level. So what do we know? We have a sample of 25 cars, so we know N. We don't know the sample mean, right? We need to find this out. And we do know that our alpha is, if our 90% confidence, then our alpha is 0.10. So our alpha over 2 is 0.05. And we know our degrees of freedom. That is n minus 1, so that's 24. So we're missing this. We know this, alpha over 2. We know the degrees of freedom. We know n, but we don't know s either, right? So we're missing s, the sample standard deviation. Well, here's the great thing. We can use Excel to find all of the missing information. So how do we find x bar using Excel? Remember from before, we can find the average of all of these. So our mean is 96, our sample mean is 96.52. Now you can also find the standard deviation in Excel, STDV, standard deviation. You can do .s, that works fine too. Oops. Or just standard deviation. And we want the standard deviation of all of this. And we get 10.7. So we actually get all the values we need. We just need our t value, right? We need this t value. So our alpha over 2 is 0.05, 24. And so we can do t inv. So it is 1 minus alpha over 2, 1.05, 24, and we get 1.71. And you could also have gotten that from the table. So now that we have these values, we can type them in, or we can plug them in, excuse me, plus or minus 1.71 times 10.7 over the square root of 25. And so you can use Excel to type to get your margin of error if you prefer to just type that in there. We would get about 3.66. And you can write it like this, or you can write it as 96.52 minus 3.66, which is going to be 92.86 and 100.18. So with 90% confidence, we can say that the mean of ultra green cars falls between 92.86 and 100.18 miles per gallon. That's a lot of miles per gallon. All right, let's take a look. Here you go if you want to see the solution written out. And again, we actually just did this critical values here, but here it is again, reminding you how to do it for our next example as well. So a recent article found that a Massachusetts resident spent an average of 860.70 on the lottery. In order to verify the results, a researcher think tank surveys 100 Massachusetts residents and asks them about their annual lottery. We don't have a portion, I have the whole thing here. So that's from the data file. Construct the 95% confidence interval for the average annual expenditures on the lottery for all Massachusetts residents. Do the results dispute the claim? All right, so again, we are trying to find the confidence interval here, and we've got alpha over 2. This is our formula. And what do we have and what do we need? So we don't have sigma, obviously, because we're dealing with the t. So n, how many people are being asked? 100. And that means our degrees of freedom is 1 less, 99. X bar, now we don't have, be careful here, we're comparing against this average, okay? So this is not the sample average, this is the average we're comparing against. We don't know this value. And then we know that our alpha, so 95% confidence, so our alpha is 0.05, so our alpha over 2 is 0.025. And so we don't have S, but we can get that from Excel. And we don't have the t value associated with 0.025, and our degrees of freedom is 99. So we're going to get these values using Excel. So we'll go in here. So first we'll start with our average. So average, and we'll just highlight all of these guys. We know we have 100, so let's make sure we get them all. There we go. Scroll back up. So our average is $841.94. Our standard deviation, and again, you can do S if you want. It'll actually return the same value as if you just do STDev. Let's highlight all of these guys here. So our standard deviation is 217.15. We can get our critical t value, 1 minus our alpha over 2, and our degrees of freedom. And we get about 1.98. Now, you can put them over here and use your calculator, but Excel is a calculator, and you can absolutely just use Excel. And in fact, so for our lower limit here, or let's get our margin of error. So that's going to be our t-value times our standard deviation divided by the square root of n. Ooh. Yes, it wanted to give me a correction. There we go. So we get 841.94 plus or minus 43.09 just about. Or we could just say 43 if you calculated it by hand. And then you could say, in Excel, you could say, all right, the lower limit is going to be the average minus that value, 798.85, and the upper limit is going to be the average plus our margin of error, about 885. So do these results dispute the claim? So with 95% confidence, we can say that the real average annual expenses are between these values. So does 860.70 fall in this value? It does. So we really cannot dispute this claim with 95% confidence. Here it is written out for you. And go ahead and give these two a try. Press play when you're ready to see the solution. And that concludes this section.